we're going to take a look at section 4.1 here in the homework. And so let me just get my window all set up. I think this is good. I'm going to go into question number 2, which I think kind of had the bulk of the ideas that needed to be looked at. So here it is. I think I can zoom in on that a little. Okay, so we've got the information about the formula for the mean and the standard deviation here. We know that the variance is the square of the standard deviation. It says 53.7% of the world is female. We're picking 5 people at random, and X is the number of females in the group. Probability distribution is below with one value missing. So I'm just going to paste these numbers over into a spreadsheet. You don't need to use a spreadsheet to do this, but it's easier for me to kind of show you guys what needs to be done if I do it in a spreadsheet. So here are my values. I have a missing value. You just need to remember these have to add up to 1 down here for the total. So I'm going to go ahead and just say, okay, well, that value that's missing is the value that makes the total 1. So if you just take 1 and you subtract each of these other values, and just do that on your calculator, just take 1 and subtract them all, and what's left will be the missing probability here. So it's 0.34 on this one. Okay, so that's good to go. Now the mean and the standard deviation, just as a reminder, the mean requires we have an xp of x that's summed. So I would come back here and do an xp of x. And then the standard deviation needs a sum of x squared times p of x. So I'll go ahead and add that. Okay. And so to do xp of x, you just multiply each value of x by its probability, and then you have to add those up, and that's the mean. So here, the first one is equal to 0 times 0.02, and of course that's 0. If I do 1 times 0.12, I should get 0.12. 2 times 0.29, not sure what that'll be. But you just continue with this. 3 times 0.34. I'll go ahead and have Excel do them all now, like that. And so those are the xp of x's. I think I'll enlarge that a little bit. Try and get those to match. That looks good. Okay, so those are my xp of x's. And then just as a reminder, for the mean, I've got xp of x here. But I need to sum that up. So over here, I'm just going to put in a command to total those up, like that. And so that's the sum is 2.68. And so I can go back over here and put that in for the mean, 2.68. Oops, typo. Okay, that should be fine. And I'll go ahead and check that part answer. And then we need a standard deviation. So the standard deviation requires that we do x squared times p of x. So I'll just say equals, and then I'll take each x value here. It needs to be squared. Okay, and then you multiply it by the probability, which is here. So that's the formula that'll do that. So 0 squared times the probability, of course, is 0. 1 squared, it'll be 1, times 0.12, of course, that'll be 0.12 again. Okay, 2 squared down here is 4 times 0.29, so whatever that is. Looks like it's 1.16, and so on. 3 squared is 9 times 0.34. Just do the whole thing here. Okay. And then we got to add those up. So real quick, I'll just say equals sum of all those values, 8.38, and then we'll compute the standard deviation, STND And I'll just do STD-DEV for standard deviation. And go ahead and just type in the formula. So this is equal to the square root. So if you go back up to the formula for the standard deviation, we have to take the square root of this whole mess. So in Excel, you type SQRT for a square root. Okay, and I have to take the square root of the sum of x squared times p of x, so that was this number 8.38, minus my mean, this sum of x times p of x was this number here, 2.68, so I'll just say 2.68 needs to be squared. So that's my standard deviation, and I'll round that to, it says to, I'm not sure how many it wants me to round to, but let's take a look down here for the standard deviation. 2 places after the decimal it says, so I'll go with a 1.09. And then I need the variance, so I've got to square that. So let me type var, and that's equal to this number squared. I don't want to round, so I'm using all the digits there. And 1.19, we'll say 1.20. Okay, checking all my answers here. Let's see if they're good. Yeah, those are all good. Now we'll just quickly put in our bars on the histogram. So the first bar has a height of 0.02, then 0.12, then 0.29, then over here 0.34, like that. Then a 0.19, and last one is 0.04. I have a nice bell shape, not perfect, but not too bad. Okay, see if we can get that to scroll. Okay, so looks great. And then the distribution, I don't know if that's skew right or skew left, is very difficult. If I knew what the skewness was, I'm going to go ahead and guess that this one is roughly symmetric. And then it gives the formula for the kurtosis. Here it's 2.64. Anytime it's less than 3, we call it a platykurtic distribution. I'll check everything here. Should be good to go. Okay, roughly symmetric, platykurtic, that's it.